and welcome. This video is a quick tutorial, a recap, a crash course on the Tan Chord Theorem. Now, when we talk about Euclidean geometry, we talk about circles, tangents, and chords. Now, I need to get some of that terminology out of the way. So, let's quickly talk about what a tangent is. A tangent you should know from our analytical geometry course. A tangent, if I have a circle as such, and a line that touches that circle at only one point, right, like that, or let's change the line's color to make it red, right? It touches at that single point, and we call that point P. Let's say it's at that point over there, and I'm going to call the point P, and I'm going to call the line AB, right? I'm going to call the line AB as such. Oh mama. Okay, then I can say that the line AB is a tangent to the circle at the point P. That's what a tangent is. Now, the next thing you want to find out is a chord. Now, that's a chord, right? A chord is just a line that touches from one part of the circle to the other part of a circle. So that green line over there, that's a chord, right? Similarly, this yellow line over here, this is a chord, right? And if I take a black line there, if I were to make a black line as such, like so, the black line is also a chord. So as you can, from the example, we say a tangent is a line that touches the circumference of a circle at a single point, right? It touches a circle at one point. Then we can define a chord to be any line that goes from one part of the circumference, right, one point in the circumference, to another point on the circumference. And then you also know the diameter is a special chord. The diameter is basically a chord that goes from one point of the on the circumference to another point in the circumference, but touches or goes through the center of a circle, right? So I'm just going to list that over there and say diameter is a special chord. Is a special chord. There we go. Right, so now where does the Tan Chord Theorem come in? Well, the Tan Chord Theorem says the following. It says, now you know what a tangent is and you know what a chord is. When we put the two together and we relate it to a circle, we can start using something called the Tan Chord Theorem. Now, the theorem reads as follows. Let's make that red. Let's get in ellipse. Right, so there we go. That's the theorem. The Tan Chord Theorem says that the angle between a tangent to a circle and a chord drawn from the point of contact. Now the point of contact we are interested in is this point of contact over here. It is the point of contact, right, which I will call P, in which we would state that that is a tangent at. Are you all with me? This line, call this line AB. Line AB is a tangent to this particular circle at the point P. Now that is the point of contact. Now if you have a tangent that is drawn to that circle, the angle formed between a tangent to a circle and a chord drawn from the point of contact, right, is equal to the angle. Ooh, mama. Okay, terribly failing here. Is equal to the angle subtended by the same chord in the other segment. That's your Tan Chord Theorem. So what I've circled over there, that's the full theorem, right? Now if you look carefully, this is my tangent, that is the chord, that is an angle. Now any line, okay, let's make it blue. Any angle that is subtended by that same chord, that angle there. Let's get another color. Let's make it red. That angle there at the circumference. That is equal to that, which is equal to that. So basically we're saying that if I make an angle between a tangent and a specific chord, then if I subtend, I take my two fingers and I put it on these 2 points, that point over there and that point over there, and then I follow the line and I follow the line over here to the circumference and I make an angle with my 2 fingers on those 2 points and I take it to the circumference, right? Then that angle that I make at the circumference that comes from those 2 points will be equal to the angle over here. Okay, similarly over here, can you see? That's my chord. That's my tangent. There's an angle between my tangent and my chord. This angle over here. Now that angle is exactly the same to any angle that I make on the circumference. For example, this, right? For example, that there. That will also be x, because this was x. If I go from that 2 points, right, that's also x. Do you see that now? What if I take the tangent on this side? Let's get a different color highlighter. Let's go pink. I'm interested in that over there. Now I've still got a tangent. I've got this. Let's not make it red. Let's make it blue. I've got this line over here. That's also a tangent line. I've got that tangent line over there. And I've got this particular chord. Right? I've got that particular chord. And I've got an angle called the angle Y. Then any line that I make, for example, in the other segment, like that, is also equal to Y. Or this over there, that's also equal to Y. Now do you get the idea? I've got a tangent and I've got a chord. I've got an angle between the tangent and the chord. An angle between the tangent and the chord. And then I take that 2 points on the chord, right? And I take it to the other part with my fingers, like that. Okay? In other words, this point here and this point over here, point P and B. I place one finger on P, one finger on B, and then I take my fingers and I go like so together to M, or to another point, or any other point on the circumference, and the angle that it forms will be exactly the same as the angle Y. That is the Tan Chord Theorem. So what I'm going to do now is I'm going to look at some examples of the Tan Chord Theorem, right? Let's draw an ellipse there. Let's get an ellipse, right? And let's draw a tangent. Now, sometimes they draw the tangents and you don't even realize that it's a tangent, but then they tell you that this line is a tangent or that line's a tangent and so forth, right? So I'm going to make my tangents black. I'm going to take a line and I'm going to say, well, okay, there's a line and there's a point of contact. I'm going to make the point of contact blue, and I'm going to ask you to draw a chord. Now remember, a chord, but my chord must start at the point of contact. A chord is just a line from one point on the circumference to another point on the circumference, right? And let's make that green. So I'm going to draw that there. Okay, so that's my tangent. That over there is my chord, and this over here will be my angle between the chord, alpha, right? Now I'm going to call that alpha, and any angle on the circumference that is subtended by that same chord, like that, for example. Okay, let's do this professionally. Let's get a line going. We like lines, eh? Like that over there. Do you see? It starts there and it goes to that point. That is also alpha. Or if I start on that same point and I go there, that is also alpha. What if I went here? That also has to be alpha, right? All of them has the same value. Now, I'm going to call it angle A, B, C, right? So I'm going to say alpha is the angle. I'm going to say angle between the tangent and chord. Between tangent and chord is alpha. Now that's given, right? Now you can conclude that angle A is also equal to alpha. Angle B is equal to angle A, which is equal to alpha. This one here, I'm going to say Tan Chord Theorem, right? Or here, angle A equals angle B equals alpha, which equals angle C. I can say angles on the same segment. And there we go. Alternatively, I could have said that B equals alpha because of tan chord. Or I could have said that C equals alpha because of tan chord, because there's the angle, and I take my finger here and a finger there, and I draw a line using my fingers, and I go to the point C, and that's what I find. Okay, so before I conclude this, I'm going to give you a little bit more interesting example where you have more than one tangent.